Good morning, friends. Today we are going to discuss about the topic in quantum physics, that is the absorption emission topics. Two topics we are going to discuss. Now we are concentrating on absorption first. See, absorption, what is meant by absorption we are concentrate. Let's assume it is the nucleus of the atom. It is the ground state, first orbital of the atom. It is the second state. It is the third state. It is the fourth state. Like that it is the several orbitals will having. Let's assume the electron is at ground state, normal condition. Electron is at ground state. It is the electron. It is at ground state. Ground state electron. So the electron may jump from ground state level to any excited level. So it can go to the first state to second, third, fourth, like this. Any state it can move. If a suitable energy is given to the electron by giving the any radiation, energy can give the radiation like a heat or any type of radiation like light, like that, anything. The suitable radiation is incidenting on the electron which is having the suitable energy, any two different levels. That means from 1 to 3 energy level is suitable. This energy gap, this is the energy, what is given is the E is equal to the energy gap between the 1 to 2. 1 to 2 energy is there. Then this time the energy gap is equal to the given energy level. Then the electron will jump from first ground state level to third state. It will go jump from first state to ground state to third state energy level. What will happen? What is called here? Now the definition of the absorption is nothing but, see, the absorption, what is doing here? It is capturing the energy from the radiation. It is jumping from lower energy state to higher energy state. So that is absorption. This total process is named as the absorption. Now, what is the definition of the absorption? Absorption is nothing but, it is the process of the atom where the electron will capture the radiation of energy. It will jump from lower energy state to higher energy state. Here is the thing, one thing you have to concentrate here. All energy, instant energies cannot be captured by the electron because the electron will suit where the instant radiation is suitable to jump from original state to the higher energy level state only. Then only the electron will jump. If we are giving the energy from more than this one, it will go to the higher energy state. But one thing you have to concentrate, the suitable energy will have the same energy gap between the any excited levels, any excited state levels. Then only it will capture. One more time I am repeating the definition of the absorption. What is meant by absorption? Absorption is nothing but it is the process of capturing the energy of radiation by an electron. The electron will jump from lower energy state to upper higher energy level states. That is the absorption process. Now, in the absorption process, we can find out the instant radiation wavelength. How can we find out? With help of the Bohr's model equation, the E is equal to h mu, that is equal to higher energy state level value minus lower energy state value. Now, it is the given energy to the atom. Electron is jumped from higher energy to lower energy. It is lower energy to higher energy jump. Then what is the absorption wavelength? That is equal to mu is equal to C by lambda. Mu is equal to C by lambda. That is equal to E2 minus E1. Then lambda of absorption is equal to what will get the absorption value? That is equal to, now lambda I am sending, this side we are sending Hc by E2 minus E1. Now with help of this formula we can find out absorption wavelength of the incident radiation. If we know that from which energy level to electron is jump, from where the electron will jump, so lower energy state and higher energy state number values you know, Then we can find out the absorption wavelength because of h is the Planck's constant. That value is equal to, what is the value, h value? 6.6 into 10 to the power of minus 34 joule second. That is third point is joule second. This value. See the constant light velocity 3 into 10 to the power of 8 meter per second. So with help of this one, we can easily find out the absorption wavelength. So now we are going to continuation topic, emission. What is meant by emission? See, emission means, before going to emission means it is emitting. What is emitting? It is emitting the energy. Energy is emitting when it will possible? When the electron is jump from higher energy state to lower energy state, only it will possible. Now we are going to, this is the nucleus. It is the first energy level. It is the second energy level. Now like that, it is the several energy levels it is having. So third, fourth. At present case, electron is somewhere in the highest energy level than the ground state. It is the ground state. My electron is here. So that means it is having more than energy level. It is higher energy level. That means it is the excited electron. So the excited electron could not stay in the higher energy level. It will have the possibility, it will stay only in 10 to the power of 8 seconds only. 8 seconds only it will stay in that higher energy level. That means it will come back to its original state. It will come back in which manner? We are not discussing here. It will come back directly, or it will come back in the mediator manner, like that. See, it will step by step. It will go to the second level. After that, it is coming like this. It will also possible. So that is, if the electron is coming back from higher level to lower energy level. That means we are concentrating here also we are concentrating. That means 3 to 2 also we can discuss. 2 to 1 we can also discuss. Otherwise 3 to 1 directly we can discuss. But condition is here, emission process is, if the electron is coming higher energy level to lower energy level, it will radiate the energy. Now the energy is coming out from the atom. It will radiate the energy. That process is named as emission. Now I am repeating the definition once again. Emission is a process where the atom will release the energy when the excited electron is coming back to its lower energy state. How much energy will get? The energy gap which is having from higher energy level to lower energy level, it will come. So what is the value of the emission wavelength? We can find out with help of the previous equation. Same equation we are following. How? What is the energy we will get? Energy E is equal to, it is the energy gap between the higher energy state minus lower energy state. So that value is equal to same Planck constant E formula. E is equal to h mu minus E2 minus E1. So mu is equal to hc by lambda, that is equal to E2 minus E1. Then lambda is equal to, that right is equal to hc by E2 minus E1. Here also we are concentrating here. The emission wavelength is equal to, we can easily find out if we know the excited state electron wavelength and emitting, so the lower energy state energy level, then we can find it easily the emission wavelength. This is the wavelength of the emission wavelength of the electron. So with help of this one, so we are recalling the two definitions. Absorption is the process where the electron will capture the energy from, like a radiation, it will jump from lower energy to higher energy. Emission is the process, the excited electron is coming back from higher energy to lower energy, it will radiate the energy. There is a two different process. So this is about the absorption and emission. We can easily find out with help of the formula, only single formula we are having. That formula we can easily calculate the absorption wavelength and emission wavelength. So we will stop here. Next class we will continue the remaining topic. Thank you.